Make sure I'm ready. Okay, good morning, everybody. And I can't see you online, but maybe you can see me. Good morning, everyone here. So this talk is kind of divided into two sections. So I'm conscious that not everybody uses Databricks. So I've tried to make most of it kind of general stuff about why it's maybe a good idea to do some of these software engineering type things in data engineering, with some bits about Databricks and asset bundles put in towards the end. Well, I think maybe at a different meetup, the balance might be the other way around, right? Yeah, so the first path, I'm going to talk about why I think that adopting these things from software development and data engineering is an important thing. And as I said, a short illustration with asset bundles. I don't have demos or anything, just a few talking points. And for those people that think that nothing matters other than Snowflake anymore, or nothing matters other than Fabric, I think there should be enough, at least in the first bit of it, to keep you interested in what we're talking about. So I don't normally talk about myself very much in these talks, but today, I think for this story, my backstory is kind of relevant. So these days, I'm sort of like a data engineer, and I try to help data teams get a bit better at shipping their products to their users and to delivering their systems. But I wasn't always doing that. I used to be a proper programmer with pointers and stuff, and from there I kind of drifted into data with Microsoft SQL Server that came in a box like this. But even by that time, I had that kind of early software background with C++ and stuff, and I'd already read this book called Extreme Programming Explained. Now, has anyone else read this book? I think possibly only the older ones, right? So, and this was a long time ago, and unfortunately, not many other people had read this book, particularly in this world of data. So I spent quite a few years after that trying to get people who were called SQL developers, which used to be a job, a bit like being a blacksmith, and it was getting these people who were called SQL developers to embrace these things like source control and testing and automated deployment, which were very much not prevalent at the time for complicated reasons. And so all of those things are the things that are important for continuous delivery, which is a topic we'll touch on a couple of times during this presentation. And this is the original book about all that by two fellows called Jez Humble and Dave Farley. And then after all that, I kind of drifted off again into working on actual websites that do useful things. And that might seem like a strange thing to do for people who have spent their careers in like data and analytics, but it was actually quite interesting, because when you work with people who are doing Angular, let's say, you never have to have that conversation about, well, should we be using source control? This isn't a debate, yeah? And it's a debate I've had with a client in very recent memory, right? Like, I've had a client say to me, oh, Gavin, what you don't understand is that Databricks is different, and we don't need to be using source control. And yeah, that was really recent. Yeah? So, and then all that other stuff about testing. And when you don't have to have those conversations about should we be doing source control or should we be doing automated testing, it enables you to do a whole lot of other stuff because you can skip that early part. So that was really a learning experience about what's possible. And from there, I fell into this thing about DevOps and SRE, which is a rat hole that I wouldn't recommend for everyone. And if you look at an SRE job ad on LinkedIn, it's always you've got to have 10 years experience of like all of these things on the slide. And whilst I was off learning about all of those things on the slide, some stuff had been changing in data, and data engineering was kind of a thing. And companies were starting to apply some of these notions from software into their data pipelines using these tools like Spark or Airflow or DBT. Do I have a logo? Yes. Now, unfortunately, or fortunately, I suppose for me, a lot of companies and a lot of data teams were struggling with these new ways of working and these new tools that were different to maybe what they've been using before. So a lot of what I've done over the last few years has been about this, about helping teams that are doing data and data things to adopt these ways of working from software development, in the context that all the tools we use seem to change every few months. So if we go back in time a bit, this is a picture like behind the scenes at the cloud. When this fellow was at work, all processing was really batch processing. And the systems, like banking systems, used to store up all the transactions during the day and then process them at night in a big batch run. And that's why, even now, you don't get your bank transactions updated till the next day sometimes. But there's something else notable in this picture, other than like the sideburns. It's this computer, and this is an IBM System 360. And this was the first computer system to have a deployment automation tool. And it was also the first computer system to have a source control tool. And slightly more interesting, they had deployment automation before they had source control. It was also one of the first systems to support something called online transaction processing, which changed everything, right? So in contrast to the previous picture, these users could submit transactions and get a response straight away. And this opened up all kinds of things, right? Like checking inventory before we make a sale, which seems like trivial now, but wasn't. Booking of airline tickets was a massive early use case for this stuff, and eliminating forms from businesses and all that stuff. And apparently this thing in the lady's hand, this can actually select text from the CRT screen in like 1973 based on how quick the lines are going on the screen. But were these people doing analytics? Yeah, they were. And how did they prepare their data for doing analysis? Well, it looked a bit like this. So here's the fellow from earlier, and he's importing yesterday's transactions so that they can do data science, or decision support, they probably called it. But it was all a bit hard. And doing decision support or analytics required writing computer programs, writing statistical programs using maybe compiled programming languages that would have been kept in source control, maybe deployed with their deployment tool. And all that stuff was a bit difficult until SQL came along. Using SQL interactively, some users can create and maintain their own databases without programming or administration. Now that sounds a bit familiar, doesn't it, right? I'm sure many of us are familiar with other tools that make promises like this. You can do analytics without programming or administration. But this quote is from the release notes of version 1 of DB2 in 1983. And this, I think, is an important part of the story here, which is that in the beginning, all of these things that we talk about, many of these things that we talk about in data, these were supposed to be end user tools with no need for programming and no need for administration. As you can see, this guy here, he's definitely an end user. He's got the cufflinks, and he's here doing some self-service analytics. But meanwhile, I think, you see, this is an AI slide, I think. So in modern software, everything had changed in the ways of working. And in order to get away from all these problems that had been discovered in software, not least in the development of OS 360, people started to work on, let's say, smaller increments. People used to get shorter feedback cycles. People had improved automation to get away from, the risky deployments, the stale requirements, and all that stuff that's in the backstory of Agile. And the automation helped them with getting rid of these laborious tasks, such as testing every time we do a new release, or such as doing deployment. And in application development, we had frameworks to facilitate all of these things. But meanwhile, what was happening in data? I think we were kind of in a strange place in data. And so we had these operations-oriented people, such as this chap here, who were very concerned with things like reliability, with uptime, with performance. And that included hardware and operating systems and software, and really a kind of sysadmin perspective. And at the same time as that, you had these people here, the analysts, and they were more concerned with maybe Excel, maybe SAS, maybe R. But in this time, which is, I'm going to say, just over 10 years ago maybe, both of these people were called data professionals. And I went for a job interview during this time. It was at a consultancy that doesn't exist anymore. And the job was to do something called Power Pivot, and that was a predecessor of Power BI for those of you that have been around a long time. And it hadn't been released yet, so that's how long ago this was. And so I went to this interview, and all the questions were about NetApp SAN configuration. So you know how it goes. You get to the end of the interview, and they say, "Well, do you have any questions about the job?" I'm saying, "Well, yes." Right? all those questions about NetApp SANs, what do they have to do with the job? Well, the answer, nothing, right? But he says, I'm the head of data, and the only thing I know about is NetApp SANs. So those are the questions we ask, and that's all about this. This whole lumping together of these two groups of people into one thing called data professionals, but we do have something in common. And I think it's that a lot of what these people do is referred to as scripting. Whoop, I've got a slide out of order. So a lot of what these people do is referred to as scripting, where they do software development light, meaning they write scripts in SQL or in Perl or in Bash or something, or they write scripts in VBA or R or something. And it's software without all the hard software stuff, like version control and like release management. It's software light. I think the slide's deleted. Right, never mind. So all that resulted in a bit of unpredictable consequences, which was we have these complex assemblies of scripts that end up being hard to manage. They're hard to deploy because you have these scripts, they tend to contain embedded configuration. And we all remember people who go from job to job with, in the old days, a flash drive, maybe now something else, full of their scripts that they use to do the thing. So the way out of this was going to be low-code data integration. And so these graphical tools that emerged, they weren't software at all. They were just pictures. So there was no need to do the software stuff with these things here. But these tools themselves can be problematic, right? And I think the root of the problem is that they never seem to get the level of abstraction quite right for the task we're trying to accomplish. And that's a whole other talk, and it's not a talk by me. It's a talk by someone called Dave Farley, who was on the cover of that continuous integration book, continuous delivery book earlier. And you can look that up online. As a result of all this, we end up enhancing these workflows with more scripts. Either by we embed the script in the workflow, or we embed the workflow in the script, or we embed the script in the workflow that's in the script. And at the same time as all of this was going on, the kinds of systems that these data professionals were delivering was also changing. We weren't just doing those point-to-point integrations anymore. We had data architects designing things called ETL. So software had moved on into modern ways of working, but ETL was still heavily focused on this overnight batch processing. And every day, the OLTP system, a bit like this fellow with his tapes, was storing up all the transactions during the day. And every night, we'd load them all into a data warehouse. And sometimes, this takes a long time, right? Sometimes this takes so long that it didn't finish before the users came in at 8 in the morning. And how much time did we spend doing non-optimal optimization in order to get things into that 8-hour window overnight? And the real killer with all that stuff was testing. So we've got a thing that takes 11 hours to run, let's say. Now, to make sure it's all working, if we make a change, we're going to do a test run. So we're going to do a test run of our batch. And we're going to write the results to our staging data warehouse. And we're going to have a look to make sure it all looks OK. If that takes 11 hours, how many changes can we make every day? What if we want to save some money by using smaller compute for the test environment rather than the main environment? So now the test run takes 22 hours, maybe. And if we make a change and we ship a change, and we accidentally have the wrong number of decimal places in some measure. But what does this encourage us to do? It encourages us to package up our changes into larger releases so that we can test everything at once. But now the users are annoyed. Because this fellow here has been waiting a week for his report to be fixed, and now it's late. Because someone from another office who he's never met has shipped a change that he doesn't care about, that's writing the wrong number of decimal places into a measure somewhere. And now it's going to take 22 hours whilst we retest the batch before his report can get fixed. What are we going to do? Well, just this once, we can make his change straight in production, right? And we can make a note in Confluence so that it's all properly documented. And so we end up with these systems like this that are difficult to understand, difficult to reason about, and to maintain, and they're difficult to test. Because we plug our scripts into our tools, into our scripts. We have these handoffs between those different environments. Having done all that, it's very difficult to replicate these systems between our production and test environments, assuming that we even care about that. Now, a lot of companies will tie themselves in knots with all of that stuff. But meanwhile, there were some boffins, which I think is a word we need to reclaim from the sun, who worked these Silicon Valley type unicorn companies. And these were the first really like wholly data dependent businesses. I think that's quite an important part of the story. So those companies in their unique position had these big volumes of data, however we want to define what big data is. And the whole analytics thing was important, crucially important to them, but also to a lot of other people. And it's really those huge businesses that are drivers of realizing that we kind of have to do better in data, only by applying the things we already knew how to do from software. And part of that is these tools that they enable our data processes to be defined programmatically rather than by drawing or by having scripts that are not testable. And again, a lot of these tools here originate from, not Spark, but a lot of these other tools originate from those big tech companies who were the first to feel those pains with the state of ETL. What all these tools have in common is that they enable us to use general purpose programming languages to define our transformations or to do our data engineering. And when we use general purpose programming languages, we get for free, we already have tools for testing, for quality, and we already have tools for packaging, and we already have tools for deployment. Whereas with, let's say, those graphical tools, as we're aware, we end up writing all that stuff from scratch with scripts. So having got all of that, we can go on to do the things that we need to do for this continuous delivery. Now, what are we talking about when we say continuous delivery? So this is what enables us to deliver changes or value to the users safely and quickly. And it starts with these foundations. Configuration management, which sounds like one of those old ITIL things, but doesn't have to be, right? Configuration management in this context is all about how easy is it for us to stand up another environment that's the same as all of our existing environments. And that can be a hard thing to do. Continuous integration, which we've touched on, that's really about source control. And more specifically than that, about frequently integrating or merging our work or our branches together. And continuous testing. So the continuous here is as often as we integrate our changes with everyone else's work, that's how often we need to be doing testing to make sure that our tests don't break anything. And on top of this, these enable 5 principles. Building quality in. In these terms, this means we don't wait until just before we're ready to release something to make sure that it conforms to our standards or to make sure that it all works, it's been tested. And the big one here, small batches, that's actually the key to all of this stuff. And all these other things on the slide, and indeed in the talk, enable this. Not least automation. So with automation, that's what enables us to do. Oh, on every commit, we're going to test everything. And finally, there are some less technical considerations also enabled by these things. Continuous improvement, which is only possible really if we can have tests. And shared responsibility. Now, all these things are connected. If we have tests, if we have automation for the tests, it's easier to build quality. It's easier to continuously improve if we have more tests. That enables us to work in smaller batches. As all the automation reduces the overhead of releasing something, and by doing small batches, we reduce risk. And the goal of all of this is to reduce risk. And reducing the risk is what enables us to go faster. So if you can do a deployment 10 times a day or 100 or 1,000, it stops being such a big deal. But what does this stuff look like from a technical perspective? Well, most of when we talk about CI/CD, we talk about CI/CD server, which is a part of it. And that's really just the automation piece. That's what enables us to plug together all of these things. But is just having a CI/CD server like GitHub Actions or Jenkins or Azure Pipelines, is that enough? Well, probably not. And I want to step through a couple of these things here in a bit more detail to consider why they matter. So why do we do source control? I can take that from the crowd or not, right? Is it to record the history of the project, right? I was thinking about this, but I think, well, we don't really need Git to do that, do we, right? You can do that with SharePoint, right? Or you can do that with Confluence or something. Because it's a best practice. I like best practices, right? Because best practices are things that you tell people to do without actually knowing why you're telling them to do it. And it's a bit like, crossing the road to avoid a black cat, right? In case we need to make a mistake, in case we made a mistake and need to undo it. Now, this is a bit closer to it. This is kind of related to the history question, but by using the modern source control tools, it's maybe easier to see exactly what just changed, especially given that a lot of the tools we use have all that notion embedded. But the actual point is this, right? If we put up with all that pain about merge conflicts and detached heads and all this stuff, right? The reason we put up with all that is it enables us to collaborate with other people. In fact, this is why Git was invented, right? To enable that distributed collaboration on the Linux kernel. And the important part, I think, to me about Git that separates it from, say, SharePoint is not the history tracking, because they can both do that. It's the merging, or even the rebasing, which is like merging, that this enables. And we take this for granted now, but I mean, I can remember, not so long ago, working on projects with older source control systems, where there was an integration team that spent weeks on merging the code from our release branch into the production branch before it could be deployed. And that wasn't a mainframe project, right? That was like a .NET and SQL Server and data warehousing type project. So it's not just memory. And I can't even remember, in like Brashnell, were those things even called branches? I don't even know. So if you're a solo developer, do you really need Git? Maybe you don't. Right? But the thing is, it's a best practice, right? And I think it's certainly the case now that it's so dominant that a lot of the tools we use assume that we're using Git, right? So we get all of those features, but not least of those is these CI servers. So why really continuous integration? So about 20 years ago, there was an influential article by someone called James Shaw that was called Continuous Integration on $1 a Day. And the point of this article was that you didn't need these fancy tools. At the time, fancy tools were cruise control to do continuous integration. You needed the rubber chicken. The rubber chicken basically acted as a mutex, right? Only the person who was holding the chicken was allowed to be at the computer that was holding the repository, merging their code into the repository. And pre-Git, that's how it worked, right? So this stopped simultaneous updates. And then there was a bell to ring if everything built successfully and all the tests passed. What was the point of all this, right? And the point was that everything is easier, all that stuff is easier if you work in smaller batches. Because the smaller the amount of change you're making, the easier the time you're going to have integrating it. And if a test fails, you have a good idea why the test has failed. And their rules back then was that everybody had to integrate their code and make sure that all of their tests were passing at least twice a day. So is anyone here merging twice a day to main now? And these people had automated tests in 2006 to validate that what they were merging was all working. Now, of course, now there isn't a single CI tool that costs as much as $1 a day. They're all cheaper than that. So any of these tools can make it really easy to merge code. Any number of times per day, we get a nice screen showing all of our changes. And Git has done almost all the work of getting our code ready to merge. But do we actually merge multiple times a day? On the subject of tools, is anyone here still using Jenkins? No hands. You see, everyone who doesn't have their hand up is lying, right? I went to a client once, not many years ago, and they were using GitLab, and they'd invested in like the whole thing, all those expensive features of GitLab, like the package registry and the security scanning and all of that, right? This was a very big client. So in addition to their strategic GitLab platform, they had 800 individual VMs all running Jenkins servers that had been stood up by teams over the years. So even if you think you don't have Jenkins, it's there in the office under the desk. Well, so most of us are doing integration maybe not continuous. We eventually merge our changes with everyone else, but probably not quite often enough. But the more frequently we merge, the smaller the change. The same as with rubber chicken. The smaller the change, the easier it is to understand. And the smaller the change, the easier it is to test. And the less likely it is to break something. And the reason we don't do this in data is when we get a design like this from the data architect, and we count all the tables, we say, oh, 7 tables, that's 7 tickets. We load them all up in Jira, and off we go. But what we forget is that in order to develop this bit, we might have to change all of these bits. And now it's not quite such a small change. So we'll go away and do that. But in the meantime, someone else has merged a change that affects these bits. And now we have a conflict. So how could this have been avoided? Well, by making the tickets smaller and by merging them more often. But isn't merging itself a painful process, reviewing all those pull requests? This is the same set of tools as we had on the other slide about CI. They can all do automation of everything else too. What can they automate? They can automate all of this stuff, the stuff that makes code reviews a pain. These tools exist for every programming language, basically. For Python, we have like rough and black and that stuff, maybe white source or sync for that dependency scanning, or Sonar or Vultr for these things about finding unoriginal code. All of these tools can find some subset of these problems in the code. The things that we complain about for pull requests. Some of these things are free, some of those things are not free. But what do we get for the money? We get never having to think about any of this stuff again. And really, that's a bargain. And by doing that, we've reduced the overhead of merging those pull requests, meaning we can do it more often. We haven't even run any of the code yet. All these tools can run our tests too, but there's a catch, right? The tests have to be expressed in code so they can run automatically. And this can be a lot of work, but what do we get in exchange for the work? Well, by writing tests, we get clarity about what it is we're changing in our system and what it is we're developing. And as our library of tests or our suite of tests builds up, we don't have to retest things. We don't have to do those regression things in the same way, because what's tested stays tested. Our quality improves over time, and we hope, I mean, I'm sure everyone's had, or many people have had this experience of trying to write tests for a previously untested system. And as we go through that process, well, the code gets easier to understand. Like the previous slide, all this contributes to reducing the number of things we have to think about in order to do work. We don't have to think about, oh, have we tested that bit? We don't have to think about, oh, is this formatted correctly, right? And another way to express that is that it reduces cognitive load. This is all about reducing the number of things we have to think about at any one time. And we talk about some people being better or worse than at multitasking. But really, I think that's nonsense. I think everyone is terrible at multitasking. It's just some people are better at hiding it. And we all know that it can be like overwhelming when we have a mountain of things to do. That can be at home or at work. And what's the answer to having that overwhelming pile of things to do? It's to do small things, do them one at a time, reduce the number of things we have to think about. So if we automate the formatting, we never have to think about formatting. If we automate testing, we don't have to think about testing so much, certainly not our old code. But this is the trap too. All right. A lot of people, especially in that DevOps and SRE world that is packed out with tools, seem to think that the automation is the point. The automation is not the point. Right? The automation is an enabler to reduce the number of things that we have to think about to do software. And maybe this is something showing my age as well, but if you think about driving a car, and think about driving a car with a broken fuel gauge, how much more stressful is driving a car without the automation of the fuel gauge? Yeah? But in the really old days, before my time, cars didn't have fuel gauges, and people still used to drive them around. And even more recently than that, people had to use rubber chickens to do continuous integration. But now we have better tools. So for those interested, I'm not sure if any of you are familiar with this, if you're interested in digging deeper into this stuff, particularly how it affects teams, I wanted to call out this book, which is super important on all that stuff, and has a load of strategies for reducing that cognitive load at the scope of the team, rather than just at the scope of the individual. But for those who are too busy to read books or even look at presentations, actually, this is the whole of Agile right here on this slide. and it fits on a Post-it note. But the problem with the whole of Agile fitting on a Post-it note is it is quite difficult to monetize. So most of the Agile training courses and Agile books are much less concise than this. You do small things and do them one at a time, and that's 90% of the battle. So how does this relate to Databricks or Databricks Asset Bundles? I think it's helpful to consider what Databricks is and what it's used for. So at the beginning, there was something called Spark, and the founders of Spark were the founders of Databricks. As the name suggests, Spark is now a project of Apache. What it says here, Spark is really a scheduling engine. And that's not very interesting, right? That can manage the doing of these data-intensive tasks across clusters of computers. And so far, so good. For some companies, that's enough. That's what they wanted. And that was enough to be getting on with. But for many other companies, all this needs to be somehow delivered in a more user-friendly fashion, particularly so it can be consumed by the cufflinks guy in front here, or even the couple at the back, who I think are the real ones in charge of those purchasing decisions. And what do these users want? These users want notebooks. I like this quote, right? So it says, yeah, notebooks are a common tool in data science and machine learning for developing code and presenting results. Notebooks are the primary tool for creating data science and machine learning workflows. You know, it doesn't say on here, data engineering. All right, and this is from the Databricks documents, right? Not from 5 years ago, from like last month. All right. Despite this, every Databricks customer you meet is using notebooks for data engineering and for ETL. Not every, I'm going to go 99. But what's wrong with doing that? Well, in the end, notebooks, whether it's Databricks notebooks or the open source cousins like Zeppelin or Jupyter, these are end user tools. Right? These are designed to create a user-friendly abstraction over whatever compute is taking place in the background. It could be Databricks, it could be Spark, it could be something else. And why is he so happy? Right? It's because this abstraction is reducing the number of things he has to think about in order to do the work he has to do, or reducing cognitive load for this fellow, the user. So all of those details about, there's nothing about scheduling on this screen here. This is a notebook. All that stuff about Spark and all that, that's all hidden, which allows the user to concentrate on the task at hand. We don't have to think about any of that hard software stuff here either. Right? We don't have to do versioning, we don't have to do testing. All of our files are here in the workspace, just like they were in SharePoint. And we can press that play button, and the code will run. And we press the schedule button, and the code will run on a schedule. So, does this remind you of anything? This is just a better version of that script-based development, like this fellow with the Perl scripts and the Bash scripts, and these people with the VBA macros and the R scripts. And notebooks, yeah, they can be hard to test, just like the scripts. But why are notebooks hard to test? Because they make it difficult to isolate these bits of code to run individually. Yeah? We get some hidden state in between the cells. Right? And it's hard, actually, to transfer these between environments without using the API. So promote this notion of promoting code from development to test to production or whatever for notebooks. All the tools that do that basically boil down to exporting and importing, don't they? All right. And when you export and import, well, you might lose your parameters at the top and all those things. And in fact, that parameter thing that's the funny thing, isn't it? I think it's clunky. It's clunky enough that it's super common to see these notebooks with environment-specific config embedded right in the code there, because no one knows when the boxes are going to appear and when they aren't, so run them. Right? And indeed, when you have a lot of notebooks, it can get even harder to debug, right? So even Databricks themselves, they're dead good at this, right? And they've got a debugger for notebooks. Their debugger for notebooks can't step into a function that's defined in a different file. Yeah? And every desktop IDE has been able to do that for 30 years. All right? So maybe there's something wrong with this kind of paradigm. Now, to be fair to Databricks with their useless debugger, right, they've made great efforts to improve the capability of these notebooks, including source control integration. And they've had, I think, at least 2 attempts at Git integration with Databricks. And they've also had exactly 2, I think, goes at creating a DSL for defining these scheduled tasks or for defining workflows. And the first one was called DBX. Did anyone ever look at this? Who's here? No, there's some Yeah, right. So this had some important features. It had this DSL for defining jobs and some CLI tools for deployment. And this was really useful. Right? I did a client project with this. The YAML syntax was a bit fiddly, let me say. And you know why, right? I think the level of abstraction of DBX over the Databricks API was maybe a bit too low for comfort. But if you could get over that, then this was, I think, the first good way of deploying those Databricks workflows. And it had some other drawbacks. It had that weird dependency on the ML flow stuff, but it definitely paved the way for asset bundles. I was thinking about this, when I first heard about asset bundles in, I don't know, some conference talk or something, I was confused about what asset bundles were. I thought that asset bundles were a packaging format, you know, like a wheel or like a gem or something, yeah, that would contain a bunch of different artifacts that would magically all be deployed and can be shipped like a binary. But it turns out not to be that, right? It turns out to be just a folder of files in this sort of defined layout. And the main file in an asset bundle is this Databricks YAML. Mine is pretty sparse. This is typical of kind of a real asset bundle deployment, right? We just include other files that we need. I think that was something that was, with DBX, harder to do without YAML anchors and so on. So this here, thinking back to my incorrect assumption that this was packaging, right? This is kind of like the manifest, right? That pulls everything together that we need. And then we're going to look at those files in a second. There's a couple of other things to call out here. It knows about building packages, despite not itself being a package. So this here is basically, before you do any of that deployment stuff, you need to build this wheel. And those are the sources. So targets is a bit more interesting, right? And again, we define the deployment paths here, as well as some cluster settings we want to run our job. So as ever, we allow more for production than we do for test. We define that using something called a cluster key, and that's going to be important when we look at the next slide. Just remember what that cluster key was. Yeah, right. And also note that for this dev environment, we say, oh, we're going to do development mode, which means something. And we can specify different paths. So in development mode, it's just going to deploy to somewhere in my home workspace folder. But for production mode, it's going to deploy to a shared path. And that means that it won't be private to a single user in production. And it was a bit of a squeeze to get this into one slide. This is the job definition that I made, right? And this is a bit of a kitchen sink job. It has a notebook and a DLT pipeline and a wheel. And this is what depends on that wheel that we said we were going to build in the main Databricks file. The important thing here is that this file here that defines my job, we're going to use that in every environment. It doesn't change. There are no references in here to dev and to test and to prod or whatever. All of that is externalized into that targets file. But we can refer to it, right? So we can refer to say, oh yeah, when we run this job on a cluster, we want to use the cluster called ETL cluster. But what ETL cluster is defined per environment in that targets file. And it's not only clusters, you can define actually anything that you want to vary per environment. You can define tags, you can define if you have config that you want to ship differently per environment. All that stuff can go in that targets file. What about testing? Well, because we're not using notebooks, there are already loads of tools we can use to write tests. We don't have to think of a way of isolating our notebook to be able to test it. We can use regular Python tools, right? We don't have to think about how to fake out, let's say a called notebook. We can import the Python file because it's a Python file, and we can use PyTest to do our testing. And we can run this test locally on the desktop, or as we can see later on the CI server. And what about deployment? Well, deployment's pretty easy, right? All right. Deployment is just like this. Databricks bundle deploy to our development environment. And we can see our job. Has all of our tasks. Has the compute settings that we created for our environment. and it has a schedule that's paused. In addition to that, the name of my job has been prefixed with dev, which is the name of the environment, and my name, Gavin, that's what I'm logged in as. Now, all of that is because the environment was set to development mode. And that's what in Asset Bundles is referred to as a preset. So a preset is a collection of settings that are probably fairly sensible for doing development deployments. Yeah? And if you're less sensible, you can change those settings. I think the most common one to change is probably, rather than my name, it might be useful to have a branch name there or something. I mean, all that can be done, assuming that you're disciplined enough to give branches names that mean something. But what about production? Oh, sorry, I'm out of order. Oh yeah, here are the source files it deployed. Yeah, right. So when we did the bundle deployment, it copied all of our source files to this folder. This is the wheel that got built and uploaded, and all that is from that fairly small amount of config. Right? I didn't type poetry build anywhere. It typed poetry build to build the wheel and upload it. And here's how it knows about what it deployed, right? And I think there's some interesting stuff about this picture, which is that we have a Terraform state file. And this goes back to my earlier thing about, well, I thought this was a packaging format, but it's not, right? This is the reason it looks like that, collection full of files is that a collection of files rather than like a gem is that this is Terraform behind the scenes. And actually, these other two JSON files here, one of them, which way around is it? Deployment.json isn't Terraform, but it's the same thing. It's the state of the source files and other files that get synced by the Databricks CLI that do deployment, right? And metadata JSON is kind of like a sidecar for the main Terraform state file that stores some stuff about the job details that Terraform doesn't have keys for, basically. But yeah, so and if we think back to like DBX and how we did deployment before, I think I certainly went down this track of trying to use Terraform to deploy all of these Databricks type artifacts because it was good and it tested and it worked. And it seemed that Databricks themselves ended up on that same track of like maybe this is a more user-friendly way of doing Terraform, especially because we can add in our source deployment without extensions to doing it. So we probably don't want the users to deploy production from their desktops, right? And that's why we have a CI server. This is Databricks' own slide, not mine. And this is about how asset bundles can be incorporated into a CI/CD type of process. So over here we can create a pull request down at the bottom there. Users can carry on deploying manually to development. But when we have that pull request, we can run all of our automation, like we can run our tests, we can run our static analysis. And when the pull request gets merged, whatever merged means, we can deploy that pull request to the real workspace. So where's that? I don't know my pointer. Right, I'm just pointing. Right. So the production deployment, this is pretty boring, right? This basically looks the same as the development one, except the schedules and enabled, right? And that was the whole point, right? Was for this to be boring. Yeah, boring was actually the goal, right? But we wanted deploying our Databricks jobs to be so routine that we could do it as often as we wanted without really having to think about it. So by doing all of this stuff, we've managed to move from doing scripts and editing our scripts and running them and being careful, because careful is slow, yeah, like to something representing or resembling software engineering, which we kind of call data engineering. By having tests, we've increased the reliability of doing our deployments. And by deploying the same thing, the same files in every single environment, which seems like, seems routine in other worlds, but it's maybe less routine here, right? We've managed to make deployment boring too. So I hope you haven't found the talk too boring. I'm just about done. And I'll be around for a few minutes longer with any questions.